In this video, I'm going to look at how to simplify when you take a derivative and you get these messy algebraic expressions, how to use factoring to get these things simplified. So a lot of times you might be doing the derivative correctly, but when you check your answer in the back of the book, you think something's wrong because you can't see where they got their answer. Problem number 13 on page 150 was an example of that. Several people asked about this. So I thought I would just go through how you find the derivative and then where they got their answer, what they went through to get their answer. Okay, so let me go ahead and take a look at that one. So when I go to do the derivative, okay, I've got a quotient rule situation. Okay, so the first thing I want you to think is, and you have a radical, is to rewrite the radical as x to the 1/2. Okay, and then now I'm going to come in and I'm going to use the quotient rule. Okay, so I'm going to do the derivative of the top, which would be 1/2 x to the negative 1/2. I'm going to multiply by the bottom function as is. Then I'm going to do minus the derivative of the bottom function, which would be 3x squared, times the top function as is. And I'm going to use the form of it as an exponent. Here, I'll put the radical back in at the end. Then I need to take the denominator and square that. Okay, so now what I'm going to do is think about how to clean this up. All right, so one thing I could do is I could distribute this 1/2 x to the negative 1/2. I could distribute that to get rid of those parentheses. So I'm going to go ahead and do that. I think it'll be easier for you to see what I'm going to do after that. However, I could have factored out an x to the negative 1/2 from this first chunk right here and then done the same from here. But I'm going to do it by first getting rid of those parentheses. So the numerator, I would have 1/2 x. And when I distribute x to the negative 1/2 to x to the third, let me do the scratch work over here to the side. Okay, remember how those exponents really should be added? So I'm really taking a negative 1/2 plus 6/2. 3 is the same as 6/2. So that would be x to the 5/2. Then I have plus 1/2 x to the negative 1/2. Then in this second term, I've got x squared, and I'm multiplying by x to the 1/2. So that's x to the 4/2 plus 1/2, which would again be x to the 5/2. Okay, I'm going to leave the bottom function the way it is. The only time I really ever have found that I want to multiply the denominator out is if they're going to ask me to do a second derivative. But even then, I might just use the chain rule in that denominator. All right, now what I'm noticing is that these two are both x to the 5/2, so I'm going to put them together. But there's some more fraction scratch work I'm going to show you. So now I'm trying to combine, and I have a 1/2 as a coefficient, take away 3. So that's 1/2 minus 6/2. So that's negative 5/2 x to the 5/2 plus 1/2 x to the negative 1/2. All of that over x to the third plus 1 squared. Okay. Now, you might be thinking, well, I have a negative 1/2. That would be square root of x in the denominator, but you can't move that, just that piece. You can't move just that piece down to the denominator because this is not multiplication. It's plus in between those two. So that's where that gets you into trouble. Okay, so what we could do at this point would be to do some factoring. We could factor out, we're going to do this a lot with the more complicated stuff, so I thought I would show you here. We could factor out this x to the negative 1/2 from the first term and from the second term. All right, now, I would personally also like to factor out a negative 1/2. You know, I have this 1/2. I'm going to factor out a negative 1/2 as well. Okay, you could wait and do that later, but I think you can handle it. So I'm going to go ahead and factor out. You could wait and do that later, but I'm going to pull, let me leave that red. I'm going to pull a negative 1/2 x to the negative 1/2 out. Really need to pull out the x to the negative 1/2, but I'm going ahead. I noticed the denominator was 2, so I thought I would pull that out while I was at it. All right, so let's see what's left. So then in the first thing, what I would need here in order to get that same thing would be a 5. That would give me the negative 5/2. Then the exponent would need to be 6/2. So when I take away 1/2, I get 5/2. And look, 6/2 is going to simplify to be x cubed. And then when I take out a negative 1/2 from a positive 1/2, I'll have a minus, and then I'm pulling out all of that second term. So it'll be just -1, but I do need -1 there so that it turns out to become positive. When I check it by distributing, I do get that same previous one. Always just check it by distributing and seeing if you've got it straight. Okay. All right. Darn it, I didn't get more paper while it was easy. So let me do my best. Get my cursor where I want it. Okay, let me just get another page here. There we go. All right, so then we just got a little bit to do. All right, so I'll leave the -1 on top. I could leave the -1 on top. I'm going to move the 2 down here. I'm going to take the x to the negative 1/2 and make it a square root of x. On top, I'm going to have the 5x to the third minus 1. I took the 6/2 and rewrote it as a 3. And in the denominator, I have an x to the third plus 1 squared. Okay. And then one thing you might do is think of that negative as just being out in front. This isn't more simple, but this is just how to deal with that. Okay, so you might think of it like this, and that would be correct. Or you could take that negative and distribute it and think of it as 5x to the third negative and then plus 1. So do 1 minus 5x to the third. That means the same thing. So part of your challenge is going to be when you think you've done the derivative correctly, which would be this part. I'm going to be checking that part first. Is that right? And then from here to the end, we're using some algebra skills. And I wanted to show you that idea of factoring out, okay, factoring out the common factor. And I won't say trick, but an idea that winds up working well is to factor out the smallest exponent. So see here it was 5/2, here it was -1/2. I'm going to factor out an x to the -1/2. And I could have left this part, the -1/2, I could have left that on the inside and dealt with it later. Okay. All right. Now, let me go to the algebra review. We're going to do some of this in class, but let me go there to that second page where we work on simplifying stuff. And let me kind of talk through this, and then I'll post the completed document along with the video. Okay. So on this, what I've got for you are what would have been the result. Somebody's already done a derivative, and this is what they wound up with. And then now their task is to try to get this to look better. You know, it's just really messy. So one of the things you notice is that this x squared is getting multiplied by what you see here. And pay attention to how that's all times within these chunks right here. So where that negative x to the third came from was taking the x squared, the 1/2, and the -2x. That all gave me this, okay? And then I had the 1 minus x squared to the -1/2 left in that first term. And then on the second piece, all I did was write the 2x in front and left the 1 minus x squared to the positive 1/2 at the back. All right, so this is the little idea that works really well to give you a very nice and clean looking final answer. All right, do you see how this 1 minus x squared is the base of both of these? What you can do is take the smaller exponent, okay, so the negative 1/2. So take 1 minus x squared to the negative 1/2 and factor that out. And then what I'll do sometimes is if there's an additional thing I notice that I could factor out, I go ahead and do that also. So I thought I would go ahead and pull out a negative x and the 1 minus x squared raised to the negative 1/2 power. Then you notice how here we had 2 terms. So here I'm going to have 2 terms. And I'm trying to see what would be left if I factor out all of this from those. So I would have an x squared left from the first term. And if I pull out the x and the 1 minus x squared to the negative 1/2, I'd need a 1 right here. See, this and this exponent and this exponent, once that's distributed, would have to add up to be a positive 1/2. And then I pulled out the x and I pulled out a negative, which means this would now need to be negative. Okay, so I just have the 2 left. The x is out in front. Okay, the x is out in front. So all I have left is minus 2 times 1 minus x squared to the first power. Okay, now here's where that helps quite a bit. See, the x squared minus 2 plus 2x squared is what I'd have once I distribute. These are like terms and give me 3x squared minus 2. And then I already factored out that other part. All right, so what I can do is now, since this is times in between these, I can move the 1 minus x squared to the negative 1/2 to the denominator, making it positive 1/2, which is really a square root. And I can leave that negative x, 3x squared minus 2, like that because that's factored form. It's also okay to put the negative like there, okay, if I wanted to. Okay, or you might have even left the negative. Anyway, I'll just stop at that. There's a lot of variations that are about equivalent. But this is a really great way to do it because we got it rewritten so it's a single term. That's why it's preferable to leaving this. Like if you had just taken from that first step, if you had rewritten it, you might have left the negative x to the third and then written 1 minus x squared to the positive 1/2. And then left the 2x and the 1 minus x squared to the 1/2 here. And then you would change to a radical. It's not really quite as good, even though you might still get credit for it. But you have 2 different terms rather than just a single term. So I'd really love it if you would practice just trying to use factoring to really simplify this so it looks very nice. Okay, and that'll help you get something more similar to what you see in the back of the book. So let me talk through why this turns out the way it does. Okay. All right, so first I'm just looking at each of these because these are the terms that are separated by just multiplication. Okay, there's only multiplication between the parts of it. So the first bracket is just this. The second bracket had a 2 times a 1/3, which is 2/3. It had an x times an x, which is x squared, and then it had the x squared plus 4 to the negative 2/3 power. Okay. All right, so then on top, I'm noticing that I have the same base. And so this would be the smaller exponent. So I'm going to factor out x squared plus 4 to the negative 2/3 power out in front here. So I'm going to see what's left from this first chunk and what's left from the second chunk. So if I factor out a negative 2/3, x squared plus 4 to the negative 2/3, I have to have a 1 here because these exponents would have to add to be 1/3. Okay. And then if I factor all of the x squared plus 4 to the negative 2/3 out, all that's left inside is 2x squared over 3. Okay. So then what I can do is, since that's a negative 2/3, that can move to the denominator and become positive 2/3, because this is times now, so you can do that. And then this is x squared plus 4 minus 2/3 x squared on top. Okay. So then I'm going to go and I'm going to say, well, look, I've got this and this. This is multiplication here. So I really have x squared plus 4 to the 4/3. These would get added, wouldn't they? Those exponents. That's where the 4/3 came from. And then 1x squared minus 2/3 x squared would be 1/3 x squared, still with that plus 4. Right? And that's pretty good. It's just that I've got a little fraction inside of a bigger one, so I have a complex fraction. So I would multiply by 3 on the top. As long as I do that on the bottom, I'd be okay. Okay, there's no exponent on this other than a 1, so that's why it's okay to distribute. And you get x squared plus 12, and the denominator stays 3. You can't distribute the 3 because of that being raised to the 4/3 power. So the 3 stays where it is, and I have the cube root of x squared plus 4 raised to the 4th power. Okay, that's a pretty good way to leave it. Okay. All right, you really could take out one of those x squared plus 4s and leave just one underneath, but I don't think it looks any better. What I mean is, if this is to the 4th power and you have a cube here, you really could bring out an x squared plus 4. That would use up 3 of those and then leave one of them under here. But that doesn't look as consolidated, so a lot of times we don't do that. We just leave it like this. Okay? All right, so again, these expressions that I'm starting you with are things that you would see sometimes when you're doing derivatives, and they look real messy, and I'm trying to teach you how to clean them up nicely. Okay, this one's not too bad. All right, notice down here I have it to the 1st power. I've got times, and I have x squared plus 3 to the 2nd. That's where the x squared plus 3 to the 3rd came from. Okay, then on top, what I did is I left this alone out in front, and I'm working on everything up on top here. So I'm distributing the 3 and distributing the 2x to both. And watch it, because that's got a minus there. So you should be thinking about that like minus 2x times the 3x minus 1 when you do this piece here. Okay? Ooh, I messed that up. Just noticed I messed that up when I wrote it. So this would be 3x squared plus 9. And then that would really be minus 6x squared. And that should have been minus times a minus. That should have been plus right there. Okay, so let's just correct it as we go. Okay, so then I would have a 2 times a 3x minus 1. 3x squared minus 6x squared would be negative 3x squared. And then this would be plus 2x plus 9. Okay. All right, now I don't like this negative on this leading term right here, so I'm going to factor out a -1 from all of that. And when I do, that gives me a negative out here in front. But if I do that, then this would be 3x squared. This should really be a minus 2x and then a minus 9. Okay, and I'll fix that when I repost it. Okay. And then doesn't appear to be anything else I can do, because 3x squared minus 2x minus 9 doesn't seem to factor in any nice way, right? That would be what I would try. But whether I use a 9 and a 1 or a 3 and a 3, there's no way for me to come up with a middle term of 2. So this would be a good way to leave it. Okay. All right. So let me stop sharing that and get it posted as well.